Okay, section 4 of the notes, we're covering the volumes and average value. I'll certainly, this is a lecture portion. I will go through this. I'm not going to read it verbatim to you, but we'll talk about this and how it relates to what you're expected to be able to do in Math 122. And this is sort of the review of what you did in Math 121, but you may not remember that, or your teachers may not have done it completely in Math 121. There's a little bit of overlap between the two classes, 121, 122, and this is part of the overlap. So I'll go through these examples over here. I'll talk about it. Certainly as I talk through this, hopefully you understand what's being said, but I do want to encourage you, if you have trouble understanding what's written or what's said to you, that you want to come by during office hours and get those issues resolved. You just don't want to let them build up and say, I'll take care of it when the exam comes. It's too late by then. You get it done quickly. All right. We're also going to talk about average value, and I'll try to, indicate that when you were taught averages when you're in grade school, it's really the same thing now, but these are going to be infinite averages, and they're a little bit more complicated to even consider, but we'll go through that. We'll talk about how to get the formula. We'll talk about little pictures over here, and then we'll go to examples. Again, part of this is me, lecturing, going to examples. The goal, though, is to get you to do work on your own. So we present things to you. It's like a show and tell almost. But part of show and tell, someone's like showing someone your brand new car. Eventually say, well, maybe I want to get a brand new car and drive it around. We give you that opportunity. Here's the opportunity. We go through something, we show and tell you, we talk about what's expected, and then we have some problems for you to try on your own. And we want you to try them. We really do. And again, if you need help, please consider getting help with that. All right. I'm going to switch to the whiteboard. And I'm going to do it. Or try to do it, right? Again, if I make any mistakes, those mistakes will be clarified and corrected. All right. So the first thing up is, and I realize, I have a trouble with this too, by the way. It's not looking at pictures and what are they showing me? Well, if I read it says, find the volume of the solid whose cross-section perpendicular to the x-axis are isosceles right triangles. So I think I'm seeing what they're saying over here. So I think I'm seeing this triangle over here. And I'm going to make a little tiny, boxy object out of that. All right. So how do I get the volume of that little boxy thing? Well, I need to know what the object is, and that's a triangle. And what kind of a triangle is isosceles? So I realize somebody says, I don't know what the word isosceles means. It means two of the sides are equal. So they also want to say it's a right triangle. And they're saying two of the sides are equal. So, this dimension here is identical to this dimension over here. Then the question is, what is a dimension? It changes. So as you move along the path, it changes. Starts out at 0, it eventually ends up to a value of 2, but it changes. So what I need to do is I need to find the equation of that line. So I'll put this over here. The equation line is going to be y equals, I'm kind of looking, I see the y and x axis over there. What's the slope over there? Well, it looks like a rise of 2 and a run of 4, x plus 0. All right, now what does it simplify to? X over 2. All right, so I know the dimension of this object at a given location along the x-axis. And let me point out to you, no matter where I am along the x-axis, I know the height of the object is this over here. The base of it is also the same thing. So what am I going to do? I'm going to take the surface area. So I'll outline the surface area. This is the surface area. I'm over here. And then I want to do the thickness of it next. Let's do the surface area first. What's it going to be? Well, area of a triangle, right? So it's going to be 1/2. This is surface area now, times the base, which is x over 2, times x over 2. All right. Now what's the thickness of it? Well, the thickness of it's a differential. We're moving along the x-axis, so it's dx. So now I got the volume of that box over there, and then I got to add them together. Where's it starting? Well, the first box starts at 0. The last one stops at 4. So 0 to 4. So I set up my integration, and what do I got to do now? I got to do it, and then I'll check it with the key, of course. So what do you get over here? 0 to 4. Well, let's see. The bottom is 1/8, right? So 1/8 x squared dx. I got to keep moving. I'm sorry about that. 1/8. This would be x cubed over 3, 0 to 4. Yep, I got to do the arithmetic. 24 the top would be what, 4 cubed, right? We'll do that later. Minus the lower limit's easy, it's just 0. So I got to do the arithmetic. And what do you get? Well, I got to reduce it by 4. So you get 16. I'm reduced by 4. And 4 goes into 24 6 times, right? I can reduce it again, divide through by 2, and you get 8/3. So the volume is 8/3 cubic units. Let's go back and see how they did. And I'm seeing this over here. All the work is down there, minus the scratch work on the side, or the chicken scratch. Let's go to average value. And for a lot of students, averages are tough. Like if you give someone a set of numbers, you say it's an average. And let's say I had a set of numbers like this over here: x1, x2, x3, yada, 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 up to xn. That's a finite set, by the way. What would I do? I would do x1 plus x2 plus x3 plus yada, 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 up to xn. And then I would divide by the total number in that set, which is n elements, and this would be known as an average. All right, that's pretty, certainly the averages are introduced to you in grade school, and it's very simple examples with averages. So now they're saying the average value of function, and this gets more difficult for me. So I'm going to draw a picture of it. And what I mean by that is I got a function over here, and they want to know its average value. So what I'm going to claim over here is that I'd have to start taking sample points. Like I might take a point here, a point here, a point there, a point there, a point here, a point here. And this is just a sample average. I'll put this over here, sample average. I didn't take all the points, by the way. So what would it be? I would say, this one over here would be x1. Then take another point over here, x2. Take another point over here, x3. Another point over here, x4. Another point over here, x5. Another point over here, x6. So really the sample average of the function is going to be this: f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5. Well, I get up to 6, don't I? Plus f of x6. How many things are there? Let me count them up for you. 1, 2, 3, 4, 5, 6. Put that down. That's a sample average. Now, of course, someone says, am I good with sample average? I'm good with it, but they want the average value of the function. So although the sample sort of reflects that, they want the actual average of it. So I got to take every single point in the interval, and that's going to be a nightmare. So what I'm going to point out is that we've done something like this before, and I'm going to go something what we've done before. We've done area. And let me point out what I mean by that. So I would say x1 here. I drew a little rectangle in there. I hope you remember that. x2, I draw a little rectangle in. And eventually I get over here. And I'm not sure how many I would take. I'm going to say xn. I draw a little rectangle in over here. And then there would be a limits of integration. I'm sorry, limits of the area. We'll get integration later. A to B. So what did I do over there? I did this. I went like this. I said, how long is the interval? It's B minus A divided by N times. Wow. Well, I got all the bases down. But now I got to do the heights. Let's write this over here. So it's going to be f of, oh boy, what's that going to be? x1 plus f of x2 plus f of x3 plus yada, 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 up to f of xn. Now, if you remember what we did when we first did Riemann sums, I really want to know the area under the curve. And what did we do? We took a limit. So let's write that down now. So we would take a limit now, limit as n goes to infinity. And this is where we said that this was really tough to do. There's no doubt about it, it was tough to do. And we came to that fundamental theorem of calculus. And we said this was quite simply a to b, f of x, dx. Here comes the part we want to take care of. And what I'm going to do is I'm looking for the average. I'm going to write this over here. Limit as n goes to infinity. I want to point out I'm seeing the average here. But I don't want that there. So what I'm going to do is divide both sides by b minus a. And what do you get? You get this. F, sorry about that. F, sorry about that. f of x1 plus f of x2 plus f of x3 plus yada, 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 up to f of xn over n is the same thing as 1 over b minus a. I'm dividing both sides by that, by the way. A to b, f of x dx. All right, let's talk about this. This is taking every single point along the curve, adding them all together and dividing through by n. And that's going to be what's called f average. So f average is equal to 1 over b minus a to b, f of x dx. All right, that's an important result. All right, so I'm going to say we just did the f average. Let's go to the next page. And they put the formula down here over here. And let me just outline that for you. This is something that you want to retain. The formula was derived in class, by the way. So let's take a look at an example. And the example is, it's a given example. I mean, I'm looking at it. I got a picture and all, but I'm not too worried about that. But I want to claim over here that the pictures can be helpful. So a picture is a picture of x squared times the root of 10 minus x cubed. So let me point out what I mean by that. This is the function they're talking about. And this is what the function looks like. And by the way, it's on the interval between 0 and 2. All right. So if I were looking at that and someone says you have a feel for the average, we're kind of looking at this thing, it looks like it goes up to like almost a 7, but bottoms out at 0. So the average is somewhere between 0 and 7. So I'm going to say 3 point something, a rough feel for it, right? A rough feel for an average, all right? Somewhere around 3 point something. I just don't know what it is. So I'm going to use the formula. And what's the formula going to be? Let's write this down for you. F av is going to be equal to 1 over, well, the length of the interval is going to be 2 minus 0, integration, starting at 0, going to 2, f of x, what's that? X squared, 10 minus x cubed, I'm using my formula, dx. Let's see if we can do it. And it doesn't look easy, but let's see if we can do it. I'm going to say u substitution, because I don't know the antiderivative of that. So I'm going to say 10 minus x cubed, and du would equal minus 3x squared dx, or minus 1/3 of a du would equal x squared dx. Let's see if we can do it. Let's write this down. 1 over, well, 2 minus 0 is 2, right? Now, granted, depending who your teacher was in Math 121, you may do things slightly different, but I'm going to go right to the land of u's. So if x is 0, what would u be? It would be 10. So if x is 2, what would u be? It would be 10 minus 8, which is 2. All right, I got to do this now. And I'll learn what I'm doing over here. X squared dx is minus 1/3 of a du. I got to put that down now. Okay, we'll do that later. All right, I know it looks bad. And the next thing I'm going to do is this over here. And what's this in the land of u's? It's u to the 1/2 power. All right, I got to do my integration now. To do that, I got to be careful. So what do you get over here? Minus 1/6, right? U to the half is going to be u to the 3/2. You can divide by 3/2 or multiply by 2/3. Limits of integration are going to be from 10 to 2. Now, keep going. This is going to be minus 1/9 2 root 2 minus 10 root 10. I got to clean that up, by the way. It looks really awful to me. 9 in the bottom, 10 root 10 minus 2 root 2. That's the average value. All right, let's go to the key. I'm not saying we're done yet, but I want to see if they got that answer. And I'm seeing it. They got 10 root 10 minus 2 root 2 over 9. I'm seeing that right over there. By the way, I didn't go back and read it. That's a problem a lot of students have. They look at a question and they're not really reading it. And I'm guilty of it too. So it says, given the graph, find its average value. I did that. The red line in the graph represents, let me see, the red line in the graph is, as you may have guessed, the average value. Oh, they tell me this is the average value. So let's write this down. So this over here is y equal 10 root 10 minus 2 root 2 over 9. By the way, if you want to take a computer out and do the computation, this is roughly 3.2. All right. So what I'd like to do is, I like to figure out what the C value is, and this could get tough. So the C value is, when does the function take on the average? I don't know. But I look at this thing over here. I'm going to post up for you. It looks around 1 point something. So what I want to do is I want to figure that out. And it's going to be tough. So I'm going to figure out, when does x squared? But you know what? I'm calling it C. So really what I want to know is, f of C is going to be C squared, the square root of 10 minus C squared is equal to the average value. And what's the average value? It's a nightmare. It's 10 root 10 minus 2 root 2 over 9. All right. Now, certainly I want to go back over here and point out that that might be tough to come up with. But I want to claim over here what they're asking me to do. And this is the second example over here. They're asking me to find the C. And this looks like it's going to be trouble. All right. So what I want to do is I want to look at this. And I want to see if I can solve it. And I'll go through it one step at a time. So it's going to be 9 C squared square root 10 minus C squared equals 10 root 10 minus 2 root 2. Someone says, how would you solve that? I'm not going to say it's an easy thing to do, but I'm going to give it a try. I'm going to square both sides. And by I'm not too interested in doing too much arithmetic over here, what would you get over here? 81 C4 10 minus C squared equals this thing squared. I'm not going to do it, by the way. All right. I got to keep doing this now. And it's going to get, it's a killer. There's no doubt about it. And looking at it, gee, that looks really tough, doesn't it? So that's going to be 810 C4 minus 81 C6 equals this nightmare over here. Well, you know what? I'm going to do it for you. And what we get over there, that'll be 100 times 10, 1,000, minus, it's going to be tough, 4 times 2, which is 8. And then what you can get, minus, I guess 40 root 20, right? Let me see if I did that right. 10 times 10 is 100, times 10 is 1,000, 2 times 2 is 4, times 2 is 8. Let's see, minus 20 root 20, minus 20 root 20 is minus 40 root 20. All right, let's keep going. I know it's tough. I would say if things get really tough, I'm not going to say give up, but, move on. You get 81 C6, this is 0, minus a 10 C4. And then what I get over here, let's write this down. Plus, let's see, 992 minus 40 root 20. I got to be honest with you, once you get to this stage over here, I start to realize this isn't such an easy thing to do. And throughout the semester, what I'm going to be recommending, whoops, sorry about that. That's what I'm going to recommend is sometimes things get tough. And I would recommend, if they get tough, use a machine. I gotta be honest with you. What am I expecting? I'm expecting an answer around 1 point something, right? So what kind of machine are we talking about over here? What's called a computer algebra system. Let's go to the next page. And I want to point out, they say we need to solve that. All right, so I'm gonna just go back over here and I'm gonna switch screens now. And I'm gonna switch screens to a computer algebra system. And this is not easy. I'm not saying it's gonna be easy for you. So what I'm gonna do is I'm gonna, let's take a look. I gotta stop this share. I'll come back to it, don't worry. And give me a second. I gotta open up my computer algebra system. And I know this is new to you. This is something that someone says, oh, you talk about it a few times. And it's true. I haven't talked about it much. Give me 1 second. I got to close something out here. And give me a second here. I got to do new share, right? Okay. So let me point out what we're trying to do. Remember I wrote that down before. I said, can I solve that equation? And then I got kind of stuck on it. I said it's a 6-degree polynomial. I don't think I was very good at that. So what I'm going to do is I'm going to try to solve it. All right. So I'm going to, clear the screen. And I'm trying to solve this equation over here. But I realize it's tough. I'm not saying it's going to be easy, but let me see if I can handle it. All right. So I'm going to reset. I know this is new to you. We haven't spent much time in this yet. Throughout the semester, though, I'm going to sprinkle the notes with using Sage. I'm going to say C is a variable. And the variable is C. Computer science, we define our variables. And then I'm going to say, I want to solve this equation over here. All right, so it's C squared times the square root 10 minus C cubed. Oh, you know what? I think I even wrote it wrong in my notes. That's okay. I'll go back and I'll correct that later, okay? I just noticed that. And then a double equal sign means an equation. And what's it equal to? Well, let's write this down. 10 times the square root of 10 minus 2 star the square root of 2 divided by 9. Oh boy, this looks really tough, right? And we want to solve it for what? C, don't we? Now, by the way, don't be alarmed. If it doesn't do it, it doesn't do it. We have other ways of doing it. Wow. They really didn't do much there, did they? So I'm going to say find root. Oops, sorry about that. And I'm going to use another command. I'm going to do a copy paste though. Our root is where the 0 of the problem, okay? So I'm just going to write this over here. And I'm going to say the root is between, I'm going to say 1 and 2. I have a picture to do that, right? Wow, look at that. It gave me an approximate. Now, this was beyond my skill set. I want to point out, though, I put the answer over here for you then. All right. So I can't say enough times, you got to learn how to use a calculator. All right. Now, someone says, well, that's not a calculator. That's you're using something a little bit different than a calculator over there. It's a calculator. It's what it is. It's a calculator. I'm using it as a calculator as well. So I want to go back to my notes, and I did make a copy wrong. Maybe it just wasn't seeing what I was saying, but I'm going to go back to my notes now. And again, we just used the Sage. And give me a second. All right, you're looking at it again. Let me get my, did I lose my pen? No, it's right here. So I made a mistake in copy. And someone says, where's that mistake? I wrote down C squared. It's actually C cubed. I'll correct that now. By the way, everything here is incorrect now. But I'll be honest with you, unproductive. What do you mean by unproductive? I'd be here for a very long time trying to figure that out. So what did I do? This was tough. A lot of times you're going to be presented with tough things. And when things get tough, please move to a tool. What kind of tools? Well, your brain is failing you at this point. You're going to need to use a machine. All right. What kind of machine are we talking about over here? What did I go to? I want this Sage, and I recommend it. Thank you.